Swayam Prabha. Digital India. Educated India.
Good morning, welcome back to the course. In this lecture, I will discuss 3D measurements and coordinate measuring machine. 3D measurements, specifically I will discuss 3D scanning, and coordinate measuring machine will have a lab demonstration of the coordinate measuring machine. The coordinate measuring machine that we have here in IIT Kanpur in machining science lab in mechanical engineering department is one that we will work on. Before the start of the lecture, I will just tell you what is 3D measurements, we will just recall those, then what is coordinate measuring machine and specification of this machine, the particular machine that we have in our lab, that I will give you. Then we have UCC's universal CMM controller, that is a kind of a inbuilt component. I can say if I think of the whole CMM machine, the controller that controls the machine is known as UCC. So, laboratory demonstration on using CMM, there will show you the parts, the various heads, all the axes, and we will see that what are the degrees of freedom, all those things we will see, and also we will try to measure one component that would be a kind of a standard component. 3D measurements. What are 3D measurements? 3D measurement is a process of creating measurement or virtual 3D representation of a physical object. This is virtual representation of a physical object. Okay. Now, 3D scanners are optical devices used to create 3D measurements or 3D scans. We have 3D scanners. Okay, 3D scans, if I say 3D scanners, the outputs are known as 3D scans. 3D scan is the output. Okay, there are certain kinds of 3D scanners. We have measuring arm 3D scanners, track 3D scanners, area based 3D scanners, portable 3D scanners. Portable 3D scanners could be held in hand, and for instance, I like to just scan this object. I can scan it from one view, third view, second view and third view. Okay, so that is front view, side view, top view. Any view I can think just see. I just need to see make sure that the angle on which I am scanning is also recorded in the software as well. So, I am putting the same input to the software. So, there are kinds of scanners here. So, the outputs are known as 3D scans. So, while the mainstream manufacturing continues its obsession with 3D printing, 3D scanning is act of capturing data from objects in the real world and bringing them into the digital pipeline. A recent study has reported that there would be about 15% increase in the production using 3D scanners annually. So, this is high rate, 15%. So, portable 3D scanning is actually fueling the movement from laboratory to the front lines, factory and field, driven and followed by key factors, and because they are low cost. So, greater accuracy is there, simplicity is there, convenience and flexibility is there. So, 3D scanners can scan the real object and produce a virtual image of that. Okay, it can produce this object. What are the steps for that? I will just give a brief introduction to them as well. So, before that, there are 3 or 4 types of 3D scanners. Number 1 that I am going to discuss here is CMM. This I will discuss in detail. Coordinate measuring machine. So, in this, arms can be equipped with either fixed probe or touch trigger probe heads. It is also possible to mount a 3D scanning head on the CMM. So, we will discuss this. There are many advantages that many different tools can be mounted on the portable CMMs, and making it possible to easily integrate scanning and probing. So, limitations are also there. Portable CMMs need to be fixed on the surface. So, use a physical link. So, we do not have a portable machine, we have a full-fledged 3D scanner, not a very big industrial size, but for research it is quite capable of producing the outputs that is required. So, Also we are doing some industrial consultancy here as well. So second type of 3D scanner is tracked 3D scanner. Tracked 3D scanner. A tracked 3D scanner here, optical tracking devices can track various types of measurement tools, including positioning of a 3D scanner. So positioning method can be external optical tracking device. These scanners use an external optical tracking device to establish positioning. So they usually use markers such as passive or active targets that optically bind the tracking device to the scanner. So another kind of a scanner is structured light scanner. Structured light scanner. So by structured light I means that these scanners project a pattern of light onto a part or a process when it is happening, and how the pattern is distorted when the light hits the object. Either an LCD projector or scanned or diffracted laser beams projects the light pattern. One or two or sometimes more sensors record the projected pattern. So it just put the light, and the structured light scanner, the patterns in the change of the light tells us the various profiles or the curves of the object. So this is another way. So one more type of scanner is portable. Portable 3D scanner. Portable 3D scanner can be either CMM or there are many types of portable 3D scanner. Anything that can be held in hand and taken to the machine or the component that we like to measure would be called as portable. So these are the major kinds of scanners. I am just introducing, I am not getting into details. For details we will share you the notes, and you can read them. So how does 3D scanning works? What happens when it scans? When it tries to scan, when we use CMM machine, it will try to touch the points. Okay. The first step it produces is the point cloud. Okay, I will write it how it works. The first step is the point cloud. So point cloud, I can even better put it, this is actually acquisition of the data or the shape, whatever we like to, we are trying to just, this is the first input I am getting from my surface. So this is I can say acquisition of scan. Okay. So if I need to produce this surface, the points would be produced first, this kind of curve, the points would be produced first. So these kind of points will be produced. Okay. The curve, let me say this is one surface. Okay. The points are produced, these are the points, this is point cloud. So the scanning results are representing using free form. So this is free form or unstructured form. Sometimes structured components are like we have a circle, a cone, a plane, a rectangle. When these things are known, the known shapes are there, those are known as structured forms. This is a kind of a free form. Okay. However, if you know about the curves, Bezier curves, B-spline curves, those are also there, but nowadays those are also not very significant. Even the free forms, any curvature that we need is quite possible to be scanned using the 3D scanners. So first point is the point cloud. Using the point cloud, we create a triangle mesh. Okay. What is triangle mesh? Now this is the point cloud, we will make triangles out of this. Okay. Joining a point with other point, we are trying to make the triangles. Okay. Similarly, the whole surface would be in the form of the triangles. This is known as triangle mesh. So this is actually, I would just call it mesh generation. Okay. The third step could be when the mesh is generated, we need to optimize the mesh. Optimize mesh means there are number of triangles, when we conduct the analysis or when we conduct the strength analysis or heat analysis, this is the mesh. the number of triangles makes, the more the number of triangles are, more be the computational part. So it depends upon what type of computation we need to do. So optimization of mesh to reduce the time of computation and to get the optimum shape as well, that is also important. For instance, if there are steep angles here, if the steep angles here, the triangle mesh can be the smaller triangles. Here it is a kind of a plane surface. If it is a kind of a plane surface here, so here the triangles can be of bigger size. So we need to optimize the mesh to obtain the near possible shape here. Okay, so optimization of mesh is required. Then after that, fourth point here could be the output of the mesh. So images and scans are brought into common reference system where data is merged into a complete model. Okay, a complete model, data is merged and a complete model is formed. This process is called alignment or registration, or we can call as mesh output. This is alignment or registration. Okay, so we have scanned from different views. When we are aligning those surfaces to get this specific shape, the solid shape, this is known as complete mesh output. So after that, so mesh input to the engineers, mesh input to the engineer workflows. So this output goes, I will put mesh input to the engineers. So this mesh input go to the engineers, they can create a surface if they like out of that. So they can create a solid model if they like. So these things can be created using this. So this is the next step. So this mesh input goes to the engineers. How does it go to them? It is generally produced in the STL format, .stl format. Okay. So the computer softwares can be used to clean up the scan data, filling holes, correcting errors, then improving data quality. So the resulting triangle mesh is typically exported in this format, STL format, and we can convert it into the known forms, like we can convert it into the B-spline or Bezier curves if it is possible. If not, then also the things can go. Okay, so CAD modeling can be produced out of this. Okay, so this was the brief introduction about 3D scanning. Next, where does 3D scanning apply? The major application is in reverse engineering. Okay, now I like to move to the coordinate measuring machine. A coordinate measuring machine is a device for measuring the physical geometrical characteristics of an object. This I have just explained. So this machine may be manually controlled by an operator or it may be computer controlled. So we will show you the both operations, the manual control using a joystick and CNC mode as well. CNC mode is computer numerical control. We just give the initial point, okay, this is the starting point. Now after each mm or after each 2 mm we can just give that distance. It will just recording the points on a specific plane or specific curve, or we can then change the direction of our probe. Those things can happen. This is CNC control. Manually also, like we just using a joystick, we can keep touching the probe to control the data. So measurements are defined by a probe attached to the third moving axis of this machine. The 3 axes, x axis, y axis and z axis. In z axis third moving probe is attached, so that helps us to record the data. So probes may be mechanical, optical, laser, white light and many such. Mechanical, optical is light, you know, laser, white light, all those things are. What probe we have here in our machine is the mechanical probe. Okay, it will physically touch the component that we are trying to measure. It will touch and it will produce a beep sound, and also an indicator would blink. So whenever it touches here, so this probe will use here. The machine which take readings in 6 degrees of freedom and displays these readings in mathematical form is known as coordinate measuring machine. The 6 degrees of freedom, that is all the dimensions are taken into account. and displays the readings in mathematical form. In mathematical form, the readings can be obtained like the distance between the two objects and the shape of the object. If it is a free form, it will create a free form. If we know that there is a structured form, we can select it beforehand only, that okay, this is a circle that we are going to measure. For circle, 3 points are minimum are required to measure. For a plane, 3 points are required to define a plane. For a cylinder, 8 points are required. For a cone, 8 points are required. So I'll come to them when I'll actually show you the lab demonstration. So objectives, I have just put the objectives of this lecture is to familiarize yourself with the parts of CMM, the specific CMM we have, the spectra CMM in our laboratory, and understand the principle and working of a CMM. Okay. So coordinate measuring machine include 3 major components. Number 1 is the main structure, which include 3 axes of motion, x, y and z axis. Number 2 is the probing system. As I said, we have a mechanical probing system here. Number 3 is the data collection and reduction system. Data collection, data reduction means we clean the data. Data cleaning. Okay. So this typically includes a machine controller. Machine controller is our UCC, desktop computer and application software. Now working principle of CMM. A coordinate measuring machine is also a device used in manufacturing and assembly processes to test a part or assembly against the design intent. What is our intent for design? Against that we test whether our part or assembly is trying to meet that or not. So by precisely recording the x, y and z coordinates of the target, points are generated which can then be analyzed via regression algorithms, because we can have the mathematical relations, mathematical equations which are regression algorithms as well. So these via regression algorithms, the points can be analyzed, okay, for construction of the features that we finally need in our product. So these points are collected by using a probe that is positioned manually by an operator or automatically by direct computer control. So main parts of CMM are air bearing. I will show these parts do there. So we have pneumatic bearings here. So then scales and encoders, probing system, servo motors which are just making the parts to move. So control system is here, joystick is here, software is there. Software that we use here is Tangram software. Okay. So advantages of CMM, this I should have told you after completion of the whole lecture, okay, but advantages here are the flexibility. Flexibility means we can use it manual or automated, okay. So in manual system there is a big flexibility that whatever we need to measure, if we know some initial information, basic information, we can use it accordingly, according to our requirement. The reduced setup time is there just because the only workpiece is to be set on the work table. The single setup is there, accuracy is high. So reduced operator influence is there, because operator is not actually touching or just making the workpiece or the probe to move. It is moving by itself. He is just trying to control the joystick. Once he defines the coordinates, he defines the origin, he defines the plane. Once the plane is defined by our probe, so it has fixed that plane. Okay, this is the reference plane. Let me say, if we based on this reference plane, if we do not change anything in the setup, it will measure all the things accurately. So operator influence is very less. So improved productivity because we have reduced setup time. Okay, these are interrelated. So the CMM machine that we have here, the configuration of that is, it is Spectra 564. What is 564? 5 is 500, 600 and 400 is the work area or the workspace that is available in the 3 axes, 500 mm, 600 mm and 400 mm. Okay, then scale regulation is 0.5 micrometer. Machine accuracy is plus minus 2.5 plus L by 250 micrometer. So this L is standard length in mm. So angular accuracy is by 1 second of the angle. So granite flatness, granite is the work table that we have, it is the flatness, it is the 0 grade granite. So the 2 micron per meter square is the flatness. So it is quite smooth to keep our measuring instruments on over it. So it is 0 gauge, that is thermal expansion is also 0. So probing system, this is the name of the probing system here. Machine version is CNC version. Machine volume is, as I said, 564. 564 is X. In X direction we can move 500 mm, in Y direction we can move 600 mm, in Z direction we can move 400 mm. So controller name is Renishaw UCC, Universal CMM Controller Lite 2, okay, from UK. Types of main structure arrangements in the CMM machine are cantilever. You know, this is the cantilever beam. Okay, the cantilever beam is moving in X direction. Cantilever beam can move in X direction, and on this cantilever beam we have this arm that can move in Z direction. So second one is column type. In column type we have the table that can move here. This table can move in X and Y direction. In Z direction this arm can move. Okay, so this is the column that is attached here. So similarly we have gantry. So in this you can see that this can move in X direction here. So this can move in Y direction. So this can move in Z direction. Okay. Next is bridge type is the machine that we have in our laboratory. In this we have X direction. This whole bridge can move in X direction. This whole bridge can move in X direction. This column can move in Y direction, and this arm can move in Z direction. Horizontal arm machine. So in horizontal arm machine, this is for X movement on this direction, Y, this is actually, this should be Z, this should be Z and this should be Y. Okay, Z in top and down direction, so Y in this direction. So different types of probing systems are there. We have inductive probing system, like we have inductive probing system, we have machining center arrangement. So inductive or inductive transmission is the principle in using this probe. Then optical transmission probes are there when optical transmission is the principle. Similarly we have motorized probes in which just we have the motors, and motors can just rotate the probe or move the probe. So multiple styluses probes are also there. So in the first three probes, 1, 2 and 3, we had only one stylus. So in the fourth one, multiple styluses probe, the system can be motorized, system can be inductive, but we have multiple styluses, one stylus on this like ruby stylus, then different stylus, and this stylus, different styluses are there. Okay, this is the probing system. Now application of the CMM is in aerospace, automobile engineering, reverse engineering, medical technology. It is actually applied in all these things. Reverse engineering is reproducing the products. So these three are the industrial domains. Okay, 1, 2 and 3 are the industrial domains. So reverse engineering is the general application. So with this I will just like to take a break here, and we will meet in the machining science lab in mechanical engineering department in the laboratory, and we will see how coordinate measuring machine works. Thank you.